Welcome back. This is a question that involves velocity time graph, and it reads, a car at rest is given an initial uniform acceleration of 1.8 meters per second square for 30 seconds, after which the acceleration is reduced to 1.2 meters per second square for the next 20 seconds. The car maintains the speed attained for 85 seconds, after which it is brought to rest in 15 seconds. Question A. Draw a velocity time graph of the motion using the information given above. Question B. Using the graph, calculate 1. The maximum speed attained during the motion. 2. The total distance traveled for the entire motion. 3. The average speed traveled for the entire motion. 4. The total distance traveled during the first 45 seconds of the motion. 5. The average speed during the same time interval as in question 4 above. And finally, question 6, the retardation that brought the car to rest. So if we should analyze the question, the car starts from rest and it accelerated. Okay? It is stated here that it uniformly accelerated at 1.8 meters per second squared for 30 seconds. So from rest, the car accelerated. That is the first phase of the motion. Then the second phase of the motion, it accelerated again. Okay? I know most of you would be confused with the statement, the acceleration is reduced to 1.2 meters per second squared. Do not make the mistake to assume that if the acceleration is reduced, that is a deceleration. Remember, if the question does not state deceleration or retardation, then you are at no point to assume that that is a deceleration or a retardation. The acceleration is reduced, simplifying the fact that it is still an acceleration, but the rate is reduced compared to its previous motion. So which means the first phase is an acceleration, the second phase is also an acceleration, but at a reduced rate. Then the third phase of the motion, the car maintains a speed. Okay? The car maintains a uniform speed for the third phase of the motion, after which it is brought to rest. So that is the final phase. So we have an acceleration, another acceleration, then a constant speed, and then a retardation to rest. So that is the way we're going to draw the velocity time graph. All right? So we will move on to answer question A. So question A, the velocity time graph. What we need to do, we will have the time on the x-axis, that is measured in seconds, and the velocity on the y-axis, measured in meters per second. So that's velocity in meters per second. So the first phase is an acceleration. Let's try to indicate that. From rest, the car uniformly accelerated, okay, at 1.8 meters per second squared for a period of 30 seconds. So we have 30 seconds here, okay? The acceleration is 1.8 meters per second squared. And after that, the acceleration is reduced. Okay? Like I said, that is not a deceleration. It just tells you that the rate of acceleration has been reduced. So do not fall into that trap. So for the second phase, the acceleration is reduced at 1.2 meters per second squared. The acceleration is 1.2 meters per second squared. And the duration for that second phase of acceleration was 20 seconds. So if you add that to the 30 seconds that has already been traveled, the point here will be 50 seconds, such that the difference between these two times will always give you the time that they have given you, that is 20 seconds. Then after that, the car attains a uniform speed. So it maintains that uniform speed for 85 seconds. So if you add that to 50, you get 135 seconds, right? So we have 135 seconds here. And then finally, the car decelerated to rest. We can indicate that as a downward slope. Okay? So it decelerated in 15 seconds. So if you add that to 135, you will have 150 seconds. So it means that is the total time traveled. So what next do we need to indicate? So what next do we need to indicate on the velocity time graph? We need to find the final velocities attained at the end of each phase of the motion. Okay? So we need to know the velocity attained at the end of the first phase of the motion and at the end of the second phase of the motion. All right, so we can call this one V1 and here V2. All right, so that is it. This is the velocity time graph. So if we should just summarize it, a car starts moving from rest. It accelerates at 1.8 meters per second squared for 30 seconds, after which the acceleration is reduced to 1.2 meters per second squared for 20 seconds to attain a constant speed. It maintains that constant speed for 85 seconds, after which it decelerated to rest in 15 seconds. This is the first phase of the motion, the second phase, the third phase, and the fourth phase of the motion. Now, what we will do first, before answering the questions, we will need to find V1 and V2, which are the velocities at the end of each phase of the motion. So, using V is equal to U plus AT, so for the first phase of the motion, we are going to use V1 is equal to U1 plus A1 multiplied by T1. The one indicates that we are referring to the first phase of the motion, that is the first acceleration phase of the motion. Okay, so that will be U1, the initial velocity will be 0 since the car starts from rest, plus the acceleration is 1.8 meters per second squared, multiplied by the time interval there was 30 seconds. So that will be 1.8 times 30, and it will be 54 meters per second. So which means V1 is 54 meters per second. And instead of writing v1 here, I can just write 54 meters per second. Okay, 54 meters per second. That is the final velocity attained at the end of the first phase of the motion. Okay, so remember that the final velocity of the previous event will now serve as the initial velocity for the successive event. That is, for the second phase of the motion, 54 meters per second will be the initial velocity, and we will use it to find the final velocity at the end of the second phase of the motion. So again, using v is equal to u plus at, so v2 is equal to u2 plus a2 multiplied by t2, 2 indicating that we are referring to the second phase of the motion. So the final velocity at the second phase of the motion will be equal to the initial velocity at the second phase of the motion, like we have said, is going to be 54 meters per second. So that is 54 plus the acceleration there is 1.2 multiplied by the time interval is 20 seconds. So when we do the math, 54 plus 1.2 times 20, we will have 78 meters per second. So it means that is the final velocity attained at the end of the second phase of the motion. So we will indicate that instead of writing v2, we have 78 meters per second as the final velocity. This is the velocity time graph of this motion. We have indicated the velocities and we have indicated the time intervals. That is question A. Question B1 is asking us to find the maximum speed attained during the motion. Well, if we look at the velocity time graph, the highest speed or the maximum speed attained by the car is 78 meters per second. So it means the maximum speed attained by the car is 78 meters per second. And we have already done that calculation. So we will write it in a form of a statement. B1, the maximum speed attained by the car is 78 meters per second. Question B2 is asking us to find the total distance traveled for the entire motion. To find the total distance traveled for the entire motion, we need to find the areas of the individual phases of the motion. So we can call this area as S1, this area as S2, this area as S3, and this area as S4. Okay, so we will find the individual areas and that will be equal to the distance. That is B2. We want to find the total distance traveled. So this is the diagram. We know that for S1, it is a triangle. So if we want to find the distance, that has to be the area of a triangle. All right. The diagram, if I have to extract it, that looks like this. So that is the shape of S1. We have 30 seconds as the time and 54 as the velocity. So we'll use that to find the distance. So S1 is equal to half the base times the height, since it is the area of a triangle. That will be half, the base is 30, the height is 54, so that will be 810 meters. Going back, S2 is going to look like the shape I will draw now. So that is S2. On the time axis, we have a time of 20 seconds. We have 54 meters per second here and 78 meters per second here. So that is a trapezium, and the area of a trapezium is, so that will be S2 is equal to half A plus B H, where the two parallel sides, this will be A, this will be B, and this will be H. So we will have half A is 54 plus B is 78 multiplied by 20, and we will have 1320 meters. For S3, it looks like a rectangle. So the shape is somehow like this. Okay, the time interval was 85 seconds, and the velocity there was 78. So that is S3. So using the area of a rectangle, S3 will be equal to the length times the height. So we can say 85 times 78. That will be 6,630 meters. And finally, for S4, it looks like a triangle. So if we should draw that, that is S4. The time is 15 seconds, and we have 78 as the velocity there. So the area for S4 will be equal to half the base times the height. That will be half, the base is 15, the height is 78. So if you do that calculation, you have 585 meters. So now if we want to find the total distance, that will be S1 plus S2 plus S3 plus S4. What is S1 is 810 meters plus S2 is 1,320 meters plus S3 is 6,630 meters plus S4 is 585 meters. When you do that calculation, you have 9,345 meters as the total distance traveled. question B3 is asking us to find the average speed for the entire motion. The average speed is equal to the total distance traveled divided by the total time taken. So the total distance traveled is 9,345 meters. The total time taken for this journey is 150 seconds. If you divide that, you have 62.3 meters per second. Question B4 is asking us to find the total distance traveled during the first 45 seconds of the motion. To know the total distance traveled for the first 45 seconds, we will ask ourselves, where is 45 seconds attained during the motion? That is somewhere between 30 and 50, somewhere around here, right? So which means if we should analyze that, the body might have attained a speed that was lower than 78 meters per second but greater than 54 meters per second. So we actually need to know the speed and the distance traveled during the second phase of the motion where the 45 seconds was attained. The distance traveled during the first 45 seconds. Now, if we should try to bring a portion of the velocity time graph, as shown here, we will ask ourselves, where is that 45 seconds attained? Well, obviously, that is somewhere between the 30 and 50 seconds. So, let's try to indicate that. So, that is, let's say, somewhere here. Okay, let's say this is 45 seconds, somewhere before 50 seconds. So it means that the velocity corresponding to that was lower than the 78 meters per second, as you can clearly see. So we need to know that velocity. Let's call that Vx. So we need to know that new velocity, and if we know that, then we'll be able to know the total distance traveled during the first 45 seconds. So using V is equal to U plus AT, we can say Vx is equal to U2 plus A2T2 because that velocity appeared in the second phase of the motion. All right, so that's why we're going to use those informations there. Now the question that I will ask myself again is, if from here to this point is 30 seconds, how many more seconds do I need to add to have 45 seconds? That is the time interval from here to this point. That is 15 seconds. Okay, so that is important to know. So it means the time is 15 seconds from the end of the first interval to where the 45 seconds is attained. Okay, so we will use that. So therefore, we'll say Vx is equal to U2, what is the initial velocity for the second phase of the motion? That is this point here, is 54 meters per second. So that is 54 plus the acceleration there was 1.2. It will not change. It is constant. Multiplied by the time is 15 seconds. So that will be 72 meters per second. Okay, which means V2 is 72 meters per second. As you can clearly see, it is lower than the maximum speed attained, which is 78 meters per second. So we will use that to find the distance traveled for the second phase of the motion. That is this portion here. Okay, it is a trapezium. So if we should extract the shape, this is how it is going to look like. This will be 72 meters per second. This will be 15. And this will be 54. So it is also a trapezium. And let's call that distance Sx. So we can find the distance Sx by using the area of a trapezium, which is half A plus B h, where A and B are the two parallel sides, and this will be h. So that is going to be half A is 54 plus B is 72 multiplied by h is going to be 15. And what are we going to have? That is 945 meters. So if we want to find the distance traveled in the first 45 seconds, that will be the distance traveled in the first phase plus Sx. So what is the distance traveled in the first phase? We have already calculated that. That is S1 is 810 meters. 810 meters plus the distance traveled during the first 15 seconds of the second phase of the motion is 945 meters. So 810 plus 945 is 1,755 meters. Okay, and question 5 is asking us to find the average speed for the first 45 seconds. For the first 45 seconds. So that will be the total distance traveled in the first 45 seconds divided by the total time taken in the first 45 seconds. So the total distance traveled is 1,755 divided by the total time taken will be 45 seconds. So 1,755 divided by 45 is 39 meters per second. Finally, we want to know the retardation that brought the car to rest. So we'll refer ourselves back to the velocity time graph. The retardation that brought the car to rest is the last phase of the motion, and the initial velocity has to be 78 meters per second. The final velocity, since the body comes to rest, will be 0 meters per second. And that is what we're going to use to find the retardation or the deceleration. The retardation that brought the car to rest we're going to use U4 is equal to 78 meters per second. V4 is going to be 0 meters per second since the car comes to rest. So we know that using V is equal to U plus AT, we can say V4 is equal to U4 plus A4 multiplied by T4. So if I want to make A4 the subject of the formula, that will be V4 minus U4 is equal to A4 multiplied by T4. To find A4, I will divide both sides by T4. So with that, this will cancel this. Therefore, A4 is equal to V4 minus U4 divided by T4. V4 is 0 meters per second minus U4 is 78 meters per second. And the time that brought the car to rest was 15 seconds. That is from here to here, as you can see. So going back, we can say T4 is 15 seconds. 0 minus 78 is minus 78 divided by 15. And we will have minus 5.2 meters per second squared as the deceleration or the retardation that brought the car to rest. So thank you very much for watching this video. Please subscribe to the channel, like and share our videos.